Okay, let's take a look at question 12 in sample exam 3 in Chem 11. This is a question about electron configuration, so I placed a periodic table here as a reference for you as we're working through this problem. This one says which of the following has the electron configuration AR3D2. So we specifically are looking for that. And if you look here, these are all either ions or atoms of transition metals. So just a quick reminder about transition metals. You have d orbitals, right? That's the reason why they're all in the same group, because all of these guys, the transition metals, all have d orbitals in their valence shell. And one of the things that you want to remember is that the s orbital of the next principal quantum number starts the period, but then it is followed by the lower principal quantum number d orbital. So for example, like in this row, you would be using 4s and then 3d, and then in this row in period 5 you'll be using 5s, 4d, and so on. Okay, now that's when you fill in the electrons, but when you remove electron, you have to remove them from the highest orbital first. So if you have 4s2 and 3d5, for example, and you need to remove 2 electrons, you're not going to take them from the 5, but you're going to take them from the 2. So that one would go away first because that's at the 4th energy level, so that's further away compared to the 3rd energy level. So when you remove the electron, you have to remove it from this n equals 4 level first. Okay, so that's something to keep in mind, and that will help you in answering the rest of the question. So let's just take a look at each of the species that they give us. First, we're given titanium plus. So let's start with titanium first before we go to the ion version. Titanium has 22 electrons here in the periodic table, and so let's do that configuration. Remember that all of these guys, they're in the 4th period, so we can start with a noble gas in the previous period, which is argon. So they are going to start with argon, and then 4s2, that covers the s elements, and then 2 more in the d, so 3d2. Now titanium plus means that you're removing 1 electron. So if you remove 1 electron, as I just said, you're going to remove it from the s orbital, so it's going to be 4s1, 3d2, which is not what we're asked to give, so that one would be wrong. Okay, and then the second one is sc, scandium, just the atom. That has 21 electrons, so we're going to do Ar and then 4s2 and 3d1. Again, that doesn't match the Ar3d2, so that's wrong as well. Let's take a look at Cr3 plus. Start with Cr first, which is 24 here. Cr is one of those exceptions in the transition metal electron configuration. Instead of 4s2, it actually has 4s1, 3d5. This is because the half configuration of the d orbital avoids that electron-electron repulsion in the s orbital that exists if you write 4s2, and that causes this configuration to be more stable, the one that I've written right here, the 4s1, 3d5. So what about Cr3 plus? Well, you're removing 3 electrons in that case, so you're going to have to take out 1 from here, which is all gone at that point, and then take 2 more from here, so leaving you with 3. So it'll be 3d3, and that's not what we're looking for. That one is also wrong. Now let's take a look at manganese 5. Manganese is right here, has 25 originally, so let's start with the atom, Ar, and then 4s2 and 3d5, right? Then we're trying to remove 5 electrons for manganese 5 plus. We're going to again start by taking 2 of these guys, and then 3 from here, so that leaves us with 2, so Ar3d2, which is exactly what we're being asked to find, so that's the first correct answer so far. And then let's look at option 5, which is titanium 2 plus. We had titanium earlier, and we had titanium plus, which is this one right here. So let's do titanium 2 plus. Titanium 2 plus would just be Ar, and then now you're taking 2 electrons out from titanium, so take out both of those guys. So you have Ar3d2, and that happens to be another correct answer. So we're going to choose that one as well. Next one we're going to be asked to use is scandium plus. Earlier we had scandium right here. So I'm just going to write next to it scandium plus, which is just 1 electron taken out. So Ar taken out 1 electron, that would knock out one of these 4s electron, makes it 1. So 4s1, 3d1. Not what we're looking for, so I'm going to cross that one out. The last option is nickel 2 plus. Nickel, looking back in the periodic table, is 28 electron, Ar, and then 4s2, 3d8. Nickel 2 plus would then knock out 2 of these guys, so then it will just be Ar and 3d8, but of course that's not what we're looking for, so that one is gone as well. So that means the only correct answers of all of the ones given to us is 4 and 5, manganese 5 and titanium 2 plus, and that one is choice D.